Toyota has sparked an automotive evolution that is shaking the foundation of the electric vehicle (EV) industry. With their latest innovation, EVs may never be the same. According to Toyota's CEO, the company has developed an engine poised to disrupt the entire EV market. This groundbreaking engine is unlike anything currently available, prompting speculation about a significant shift in the automotive landscape. Could this be the dawn of a new era? Let's delve into the details. Before exploring Toyota's revolutionary engine, it's essential to understand the company's journey. Known for bold moves in the fast-paced world of automobiles, Toyota is now making headlines with an audacious claim that has the EV industry abuzz with anticipation. Imagine an engine so innovative that even the most dedicated car enthusiasts are left speechless. This new technology promises to be a game-changer. Recently, Toyota announced the development of a hydrogen combustion engine, distinct from any other. Unlike manufacturers that have fully embraced electric vehicles, Toyota has charted a unique path. Their hydrogen combustion engine uses hydrogen as its primary fuel source, emitting only water as a byproduct. This innovative approach aims to minimize the global carbon footprint and presents a compelling alternative to traditional EVs. Hydrogen, the most abundant element in the universe, boasts the highest specific energy density among non-nuclear power sources. It is exhaust-free, non-toxic, and versatile. Hydrogen can be produced from various sources, stored indefinitely, and transported with ease. Millions of tons of hydrogen are safely produced and utilized annually in buildings, electric vehicles, forklifts, ships, and even trains. Toyota's hydrogen combustion engine leverages this potential, converting hydrogen into electricity through a fuel cell. An example of this technology is the Toyota Corolla Cross H2 concept car, powered by a 1.6-liter turbocharged 3-cylinder hydrogen engine. To make this vision a reality, Toyota has revolutionized EV design. Thick, armored fuel tanks derived from their FCEV Mirai store the highly flammable hydrogen. Remarkably, the Corolla Cross H2 requires only 5 kilograms of hydrogen to achieve a range of 300 miles, emitting just 50 liters of water as a byproduct, an environmentally friendly alternative to carbon dioxide. Toyota has also collaborated with Yamaha Motor to create a hydrogen-powered V8 engine, generating 455 horsepower and 398 pound-feet of torque. This engine features a top-mounted 8-to-1 exhaust manifold, producing a distinctive high-frequency sound. Compared to traditional EVs, the hydrogen engine offers significant advantages, including a longer range, rapid refueling, and reduced dependency on limited-supply materials like lithium and nickel. The Corolla Cross H2 concept car has already undergone real-world evaluations and winter testing in northern Japan, receiving positive feedback. Toyota's hydrogen combustion engine represents a monumental shift in the automotive industry. With its environmentally friendly design, extended range, faster refueling, and reduced reliance on scarce materials, this engine has the potential to redefine the future of transportation. If successful, Toyota's hydrogen-powered engine could catalyze widespread adoption. The Japanese government has ambitious plans to deploy 200,000 fuel cell vehicles by 2025 and increase this number to 800,000 by 2030. To support this transition, expanding hydrogen refueling infrastructure will be crucial. While the hydrogen combustion engine offers numerous benefits, including its eco-friendly nature and advanced water cooling system that enhances performance and longevity, challenges remain. Nonetheless, this innovative technology could mark a pivotal moment in the global pursuit of sustainable transportation. As we all know, an engine that saves drivers significant time and effort is highly desirable. One major advantage of this new hydrogen combustion engine is that it utilizes familiar technology. Operating on a system similar to traditional engines, it is easier to integrate into existing automotive design and manufacturing processes. This provides a strategic advantage for Toyota, as they can modify their current vehicles to incorporate this engine with minimal disruption. Clearly, the engine offers notable benefits that make it a strong contender in sustainable transportation innovation. However, no innovation comes without its challenges. The first disadvantage is the production and infrastructure required for hydrogen. While the engine is undeniably eco-friendly, its sustainability depends heavily on how hydrogen is produced. Currently, hydrogen production is not always sustainable, which poses a significant barrier to large-scale adoption. Furthermore, hydrogen fueling infrastructure is sparse compared to gasoline and electric charging stations, making it less accessible for consumers. This lack of infrastructure presents a critical challenge that must be addressed before hydrogen cars can achieve widespread acceptance. Another challenge is the complexity and cost of hydrogen combustion engines. Although the engine architecture is similar to traditional designs, it incorporates a dual water injection system and requires precise control by the ECU. These features increase the complexity of the engine, adding to manufacturing costs for automakers and maintenance costs for owners. Even if Toyota achieves large-scale production, market readiness remains an issue, as the production-ready version of this design is still undergoing development and testing. Commercial availability will require additional time and resources. By developing this hydrogen combustion engine, Toyota has shown its dedication to exploring diverse solutions for sustainable transportation. Alongside their electric and hybrid technologies, this engine represents a significant step forward in diversifying eco-friendly vehicle options. But how does this engine differ from traditional internal combustion engines, and what technical aspects set it apart? To answer these questions, we turn to Toyota's 1.6-liter, 3-cylinder turbo hydrogen engine, a standout innovation in this field. Currently used in the Corolla Cross hydrogen prototype, this engine combines traditional design with pioneering technology, achieving remarkable results. The 1.6-liter, 3-cylinder turbo engine is based on the same platform as the high-performance GR Yaris engine, known for its agility. To adapt this engine for hydrogen fuel, Toyota implemented significant modifications, raising questions about how the company maintained performance while switching to an entirely new fuel source. The answer lies in the hydrogen combustion process, which uses a high-pressure hydrogen direct injection system. This advanced system optimizes the delivery of hydrogen into the combustion chamber, enhancing both performance and efficiency. The engine's performance is impressive, rivaling that of its gasoline counterparts thanks to the turbocharger. However, concerns have been raised about whether turbocharging is the optimal approach for hydrogen, given its lower energy density compared to gasoline. Toyota's engineers have addressed this by optimizing the turbocharger and other components to handle hydrogen's unique properties. This attention to detail ensures the engine delivers high performance while maintaining reliability. One of the most significant advantages of the hydrogen combustion engine is its efficiency. It performs exceptionally well in high-load situations, improving fuel economy and reducing environmental impact. Most notably, the combustion process produces only water vapor as a byproduct, resulting in near-zero emissions. This aligns perfectly with Toyota's commitment to achieving carbon neutrality. By employing a diverse strategy that integrates both hydrogen and electric technologies, Toyota is paving the way for a sustainable future in transportation. Why does Toyota adopt a multifaceted approach in its quest for carbon neutrality? To understand this, we need to explore Toyota's commitment to hydrogen technology. Hydrogen presents immense potential as a clean energy source. When used in fuel cells or internal combustion engines, it produces only water vapor, making it an environmentally friendly alternative to fossil fuels. Toyota's investment in hydrogen technology extends beyond passenger vehicles. It has been incorporated into commercial vehicles and public transportation solutions. However, relying solely on hydrogen technology is not sufficient for achieving carbon neutrality. Recognizing the limitations of a single technology, Toyota has also embraced electric vehicle (EV) technology. A core component of its strategy is the development of battery electric vehicles, BEVs, albeit with a unique approach compared to other automakers focusing exclusively on EVs. Toyota's diversified strategy addresses significant challenges to EV adoption, such as limited range, long charging times, and the environmental impact of battery production and disposal. To tackle these issues, Toyota offers a range of powertrain options, including hydrogen fuel cell vehicles, (HEVs), plug-in hybrid electric vehicles, (PHEVs), and BEVs. This approach caters to a broader spectrum of customer needs and driving conditions, all contributing to the overarching goal of carbon neutrality. Toyota's strategy is adaptable, recognizing that different regions and markets have distinct energy sources, infrastructure, and environmental policies. A one-size-fits-all approach would not be as effective in reducing global carbon emissions. For example, in regions powered by renewable energy, BEVs may be the ideal solution, while areas with renewable hydrogen production might favor PHEVs and hydrogen internal combustion engines, HYSEs. Beyond vehicle emissions, Toyota actively reduces its manufacturing carbon footprint by promoting recycling, efficient resource use, and investing in renewable energy projects. However, achieving carbon neutrality will require broader systemic changes, including innovations in energy production and infrastructure. Toyota's multi-technology approach is coupled with initiatives in sustainability, showcasing a comprehensive effort to address environmental challenges. Apart from carbon neutrality, this strategy brings numerous environmental benefits. For instance, Toyota's hydrogen-powered internal combustion engines present a fascinating proposition in the shift toward sustainable energy. When compared to hybrid electric vehicles, HEVs, and PHEVs, hydrogen engines stand out for their zero carbon dioxide emissions during operation. Unlike gasoline engines that emit large volumes of CO2, hydrogen engines produce only water vapor as a byproduct, thanks to the combustion process where hydrogen reacts with oxygen. Hybrid vehicles like HEVs and PHEVs combine gasoline engines with electric motors, offering improved fuel efficiency and reduced emissions compared to traditional gasoline vehicles. However, these vehicles still rely on gasoline, resulting in carbon dioxide emissions during operation, albeit in smaller quantities. In contrast, hydrogen engines have the potential for true zero-emission driving, provided the hydrogen fuel is sourced sustainably. Another critical consideration is the life cycle emissions of these vehicles. HEVs and PHEVs use batteries that require rare earth elements, whose manufacturing processes are energy-intensive and emit significant carbon. Hydrogen engines, on the other hand, avoid these challenges, making them a promising alternative for a sustainable future. The production of hydrogen fuel, particularly when derived from renewable sources like wind or solar power, offers a less environmentally taxing alternative to battery production. This approach ensures a more sustainable overall life cycle. Furthermore, the hydrogen combustion engine has demonstrated greater practical efficiency than traditional combustion engines, especially in heavy-duty applications where it can rival the efficiency of hydrogen fuel cells. While fuel cells excel at low load efficiency, their performance drops under higher loads. In contrast, hydrogen combustion engines peak at high loads, making them ideal for high-performance scenarios. As the world grapples with climate change and resource depletion, technologies like Toyota's hydrogen engines provide a hopeful path forward, combining cleaner, greener transportation with uncompromised performance and practicality. Hydrogen engines exhibit performance levels comparable to gasoline engines, thanks to the unique properties of hydrogen as a fuel. Hydrogen burns faster than gasoline, resulting in higher responsiveness, a crucial factor for performance driving. This responsiveness ensures that hydrogen-powered vehicles can deliver a driving experience akin to conventional internal combustion engines, complete with immediate throttle response and a characteristic engine growl. These elements, cherished by automobile enthusiasts, are integral to the driving experience. Remarkably, hydrogen internal combustion engine vehicles, HYCEVs, can replicate these traits, allowing drivers to enjoy the sensation of power and engagement traditionally associated with gasoline engines, even while using a clean fuel source. Toyota has showcased the robustness of hydrogen engines through motorsports, where they have proven capable of competing with traditional vehicles in high-stress, high-demand environments. In racing scenarios, hydrogen-powered cars have displayed comparable speed, agility, and endurance. These engines deliver horsepower and torque similar to or even surpassing that of conventional gasoline engines. By modifying existing engine designs to accommodate hydrogen combustion, Toyota has achieved power outputs that rival or exceed traditional engines. This technical milestone underscores hydrogen's potential as a viable alternative fuel for high-performance vehicles, offering a blend of innovation and environmental consciousness. One critical question remains: can hydrogen-powered vehicles deliver the same driving pleasure as their gasoline counterparts? Early indications suggest they can. Test drivers of Toyota's hydrogen-powered cars report a driving experience that is both familiar and exhilarating, combining the dynamics of traditional engines with the novelty of a sustainable fuel source. By retaining the performance characteristics of conventional internal combustion engines, Toyota is narrowing the gap between current automotive preferences and future innovations. Whether for daily commutes or adrenaline-pumping racetrack sessions, HYCEVs promise to deliver performance, sensation, and enjoyment while ushering in a new era of environmentally conscious motoring. Beyond hydrogen combustion engines, Toyota is exploring groundbreaking technologies, including an engine powered by water. This concept, which seems straight out of science fiction, represents a significant leap in sustainable solutions. The core principle involves using water as a fuel source by separating its hydrogen and oxygen components through electrolysis. Hydrogen, when combusted, can produce substantial energy to power an engine, with water as the only byproduct. Toyota's exploration of this technology exemplifies their commitment to revolutionizing the automotive industry, offering sustainable and innovative solutions that could redefine the future of mobility. As we saw earlier, this means zero carbon emissions. When Toyota achieves this water-powered car, it will be a true game-changer in the industry. This would be a highly appealing technology in the context of environmental sustainability. Another intriguing aspect of Toyota's water-powered engine initiative is the filing of patents related to this technology. According to the patent filings, Toyota's commitment to developing and protecting this innovative technology suggests a serious investment in making water-powered engines a reality. But how will Toyota even integrate this technology into practical automotive applications? The integration of water-powered engines into vehicles presents numerous challenges. The major challenge here would be integrating an efficient electrolysis system into the engine. Furthermore, they would have to think about safe hydrogen storage solutions and engine designs that can handle the unique properties of hydrogen combustion. However, given Toyota's record of innovation and technological breakthroughs, these challenges are something they can conquer. Toyota has already disrupted the EV industry with their hydrogen combustion engines. When they unleash the water-powered engine, the automotive world will never be the same again. Thanks for watching, and I'll see you in the next one.